Hello everyone, I'm physics teacher and welcome to my podcast where I attempt to teach high school physics and chemistry contests to my daughter in elementary school. Say hi, Coins.
Hi.
Okay. Be sure to listen.
Can I retry that?
Why? Because it was like... You want to retry that?
No, it's good.
Alright. Alright, so be sure to listen to the end to see how she does on her final question of 5, or her final quiz of 5 questions. If you enjoy it and want a second season, let us know. This season will have 6 episodes. This is episode 2, where I try to teach you the difference between mass and weight. Alright, so now that I've said we're learning about mass and weight, do you think these two terms are interchangeable? Do you think they mean the same thing, or?
I don't know what interchangeable means.
It means, do they mean the same thing?
No.
No, okay. So, what do you think the difference is between mass and weight?
Weight is weight.
Give me an example.
It's pound stuff.
Pounds?
Yeah, like pound, grams, right?
Pounds, grams, sure. If you're curious why she came out with both pounds and grams, we are Canadian. And even though we use the metric system, many of the products we buy in stores are from America, and so everything does tend to be in imperial units as well. So we use pounds and grams, kilograms interchangeably ourselves. So if you think weight is things like pounds and grams, what do you think mass is?
I forgot.
I forgot? Did you learn about mass in school?
Yes.
Okay. Maybe you learned about, like, density?
Sure.
Sure? Do you remember density? Volume? Mass?
Oh, yes.
Yeah?
Yes.
Okay. All right. So we've already talked about what units you think they're in, either pounds or grams or kilograms. When you step on a scale, or when you put something on a scale, what do you think that scale is measuring?
Weight.
Weight. Okay. How do you think you would measure mass?
Brain power?
Brain power? Okay. No, that's not how we would measure mass. Let me explain the difference between them. Okay, mass is actually what you would measure with pounds or grams or kilograms. It's the amount of stuff something has. Okay, volume is how much space something takes up. So density would be how much stuff you can fit into a certain amount of space. So then what is weight? Weight is actually the force of gravity that pulls on you.
What?
So if you talk about something being heavy or light, that's its weight. And if you try to lift up like a desk, it's heavy, right? But if you try to lift up a piece of paper, it's light. Okay, that's weight. So it feels like it's interchangeable, right? Because if you put a desk or a piece of paper on a scale, the desk will give you a large reading, maybe like 20 kilograms, and a piece of paper might be a few grams, and you're like, that makes sense, because the desk is heavy, right? You have to say something. I can't hear you shaking your head.
It's nodding, not shaking.
Okay. All right. But here's the difference. How much do you know about gravity?
A lot.
Okay, tell me what you know about gravity.
It makes things fall.
Okay, yes. Okay. Gravity makes things fall. Do you think gravity on the Earth would be the same as gravity on the moon?
No.
How do you think they're different?
Atmosphere?
Okay, so the moon doesn't have an atmosphere because its gravity isn't strong enough to hold one.
Oh.
Have you ever seen videos of the Apollo astronauts hopping on the moon?
Yes.
Yeah. How do they hop? Quickly or slowly?
Slow.
Slowly. If you were to hop on Earth, quickly or slowly?
That depends, actually.
But okay, how quickly would gravity pull you back down? Would it be fast or slow?
Fast.
And on the moon, fast or slow?
Slow.
Okay, so gravity's different on the moon than on Earth. It's a lot stronger on the Earth. So imagine picking up something heavy. What do you want to pick up? Imagine something. What are you imagining?
A mug.
A mug. Okay, it's not too heavy, but okay. Let's say you're picking up a mug on Earth, right? And then you try to pick up the same mug on the moon. Because the moon pulls things down more slowly, it actually feels lighter to you, even though it's the same mug.
That's mass?
That's weight.
Oh.
Mass is how much stuff it is. Okay, so let's say the amount of mass the mug is 1 kilogram. This is a heavy mug, but we'll go with 1 kilogram because it's a nice number. Whether the mug is on Earth or on the moon, it has the same amount of stuff. That's 1 kilogram. But gravity pulls more on the Earth, so it feels heavier here. And on the moon, it feels lighter. That's weight. How much gravity is pulling on it is weight. How much stuff there is mass. Questions?
It's cool.
It's cool? Okay, so here's an interesting question. Let's say you were to stand on a scale on Earth. And let's say you look down and you read it, and let's say 70 pounds. Don't get mad at me if I'm wrong. This is just...
I actually don't know.
Oh, okay. So let's say it just says 70 pounds. Now, if you took that same scale to the moon and you were to stand on it, do you think it would give you the same value, or do you think it would give you something more or something less?
Less.
Less. Why?
Because of gravity?
Yes, because gravity doesn't pull as much there. So it actually gives you something less. But your mass hasn't changed. The amount of stuff you're made up of is the same.
Oh, I get it now.
Okay. Now, our units for measuring mass are, if you want to use pounds, we can use pounds, 70 pounds. Okay, units for measuring gravity is not pounds. It's not kilograms. Because it's not the same thing as mass, it's a force. Now, you haven't learned this before, but maybe you have. I don't know. Correct me if I'm wrong. But all forces are measured in what we call newtons. Of course, named after Sir Isaac Newton.
Sir Isaac Newton.
Okay.
Isn't that the guy who discovered gravity?
Yeah, he did a lot of work with gravity. Genius. Many hundreds of years ago. You know the story of the apple falling off the tree?
Yes.
Yeah, okay.
Everyone knows that
there
story.
There you go. That's Newton.
And if you don't...
So the units for force are newtons, and that goes for any force, right? If you push something, that's in newtons. If you pull something, how hard you pull is in newtons. Okay?
Is a newton.
Now, on the Earth, force would be a certain number of newtons, and a newton isn't that much. Okay? If you had your 1 kilogram mug, right, and you were to measure its weight on Earth, so how much Earth is pulling it down, right? Its weight would actually be just under 10 newtons.
Oh.
So it's almost, the number is almost, not quite, but almost 10 times as much as the number for its mass. Okay, so 1 newton isn't a lot. In fact, if you were to hold on to an apple, the heaviness of it, how much gravity is pulling it down on Earth, would only be a couple newtons. That's it. So 1 newton isn't a lot of force. All right, so lastly, let's go back to our scale. Okay, I asked you, what do you think a scale measures? Now let's talk about it again. Weight? Okay, here's the tricky thing. It actually doesn't measure mass or weight. It measures how much something is pushing on it. So imagine you're standing on a scale.
It measures gravity?
It could, right? Let's think of an example. You're standing on the scale. What's pulling you down?
Gravity.
Okay, so in that case, yes, it's measuring that force of gravity. Now, let's say your brother came along and he decided to play a little prank on you because you're standing on the scale and you're looking down on the scale, and he comes over and pushes down on your shoulders. What will the reading on the scale, how will the reading on the scale change?
It will increase.
It'll increase, right? But it's not measuring gravity anymore. It's measuring gravity plus the force that your brother is pushing down on it. So in scales, you have all these little springs, right? And when you push on it, the springs compress And that's all it's measuring, how much those springs are being compressed by. So it'll measure any force. You can hold up a scale sideways and push on it with your hands, and it will give a reading. So it's not measuring mass, it's not measuring gravity, it's measuring any force that's being pressed up against it. Now, typically, if you're just standing on it, and that's the only force, then yes, in that case, it is measuring gravity. And then knowing the value of gravity on Earth, it converts that to a mass and tells you the mass. So that's what the scale actually measures. Okay? Feel confident?
No.
No. Have any questions before we go ahead and do our 5-question quiz?
No.
No? You want to do this?
Yes.
All right. 5-question quiz. Question 1. What are the units for weight?
Grams.
Is that your final answer?
Pounds.
Final answer?
You're making me think I'm wrong.
Okay. Let me rephrase it. What are the units for mass?
Pounds.
Okay. What are the units for weight?
Grams.
They're the same?
I don't know.
Okay, think about the apple. Okay, who discovered that? Not the apple.
Newton.
Okay, what are the units for weight?
Newton.
There you go. Okay, I'll give you half a mark for that one because we had to kind of go through it.
I deserve a full mark. I deserve a full mark.
Okay, question number 2. If you went to Mars, what would change? Your mass, your weight, or both?
Just wait.
Yes, good. Okay. Just as a little bonus question there, do you think Mars has more gravity or less than Earth?
Man, I don't know.
Do you think Mars is bigger or smaller than Earth?
Smaller.
Okay. So do you think it has more pull or less pull?
Less.
Okay. Yes, it actually is about a third. Okay.
So less?
It's less. The moon's about a sixth.
Because it's very small.
It's very small.
But not really. Because we're a lot smaller.
True. It's all perspective. All right. We'll give you that one. Good job. Number 3. This is where it's confusing. In English, when someone asks, how much does something weigh? Let's say they were to ask you, how much does this book weigh? Are they actually asking for that object's weight? If you go to the doctor and the doctor says, how much do you weigh? What kind of answer does the doctor expect?
Your weight.
Which would be, give an example.
Gravity? The gravity, like...
In newtons?
Yeah.
What do you think your doctor would say if you went and he goes, how much do you weigh? And you said something like 10,000 newtons.
Make him think. Make him think.
What kind of answer? Yeah, you would make him think. What kind of answer would you give your doctor if he said, how much do you weigh?
I would say, I don't know.
Okay, it's true. Let's say you weighed 70 pounds, or let's say you weighed 50 kilograms or 500 newtons. Which would you tell him?
500 newtons.
Okay, but is that what he's expecting?
No.
What's he expecting?
Like...
Mass or weight? Don't be confused. I like...
Weight.
Nope.
Mass.
That
was my first guess.
Oh, good. Don't worry, I mess up both my grade 11s and my grade 12s. The reason why mass and weight is so confusing is because we constantly go, how much does this weigh? And people say, 2 kilograms. How much does that weigh? 10 kilograms. So we keep asking how much does something weigh, but we answer what the object's mass is. And that's why so many students always get confused between mass and weight.
Wait, so how would you properly respond?
Properly? Okay, well, properly, if someone said,
I heard a squeak from him.
She's talking about our owl. He's watching us do our podcast. You'll see the owl in a video later. He's going to appear in one. I think he's hungry. We'll train him after this.
He's clicking
his beak. He's hungry. Okay, what was I talking about?
How would you properly respond to
Okay, yeah. So if someone said, how much does this book weigh? Your proper response should be something like 30 newtons. But if you expect an answer in kilograms, then you should properly ask, what's the mass of this book? And then they can say, oh, it's, I don't know, 3 kilograms.
Next time someone asks me, I'm gonna say like something Newton.
There you go.
Gonna make them confused.
All right. I don't even know. Did you get that question right?
Yes.
Okay.
I have 3 stars.
Oh, do you now? All right. Question 4. What does a scale actually measure? Mass, weight, or something else?
Something else.
What is it?
Is it like the gravity thing?
Gravity is weight. Force of gravity is weight.
So wait.
But a scale will measure...
Oh, mass. Mass.
A scale will give you the reading for mass, but it'll measure...
The gravity pushing, you know?
Plus any other force that's pushed up against it.
Yes.
This is actually, we won't really talk about this, but for any viewer that is wondering what that is, it's actually measuring the normal force. We'll talk about that some other time. Okay, but for now, any force that's pushed up against it. Last question in your own words. What's the difference between mass and weight?
I have a question for you.
Oh, you're not going to answer my question? Okay. What's your question?
In your own words, what's the difference?
No.
But like, okay, wait, okay.
I'm a teacher. You know how many times students will raise their hand during a test and say, "I have a question. What is it?" And they pretty much just read verbatim the question that's on the test. That doesn't work.
Whatever. The difference is weight. Weight is like newtons.
Okay.
Okay, and mass is like pounds.
Okay.
Brain power.
That's good. That's giving an example of each.
I have 5 stars.
Yeah, sure. We'll give you 5 stars. We'll get stickers later. Those are examples, but I would say for full marks, mass is the amount of stuff something has, and weight is the force of gravity that pulls on it.
So basically, mass is
the amount of stuff, which, like you said, is measured in
which
pounds.
is the amount of stuff, and weight is the other
The
thing.
force that...
The force.
Of,
yes.
Of what?
Of gravity?
There you go. Which
See,
is measured
I got a
in...
full mark.
Which is measured in?
Newtons. I
There
already
we
told
go.
you.
Good job. All right. 5 stars?
5 stars.
All right. If any viewer disagrees, let me know what star
They
rating
shouldn't
you should have.
disagree. I got all 5 stars.
All right. Let us
If you
know in the comments.
disagree, I'm coming for you.
Oh my goodness. All right. We'll see you next episode.